All right, thanks for showing up. We turned out the problem yesterday with LMS was actually LMS, not something I didn't know how to work. Of course, there's still things I don't know how they work or how to work, but we'll figure that out as we go. Last I checked, all but 2 or 3 of you had taken yesterday's quiz. Due to the confusion yesterday, that is still open, even though it said due at 9 o'clock. Now, that's one of the things I'm not sure how LMS works. I don't know if it cuts you off at the due date, due time, or it lets you keep taking it. So I left it open. If there's a problem, let me know. There's another quiz for today, and that is scheduled to be done at 3 o'clock. If there's issues, again, let me know, but everything seems to be working right at this point in time. And we will try again with a simple PFG on pH at the end of this time period. That is basically set up as a short answer or essay or something like that quiz. And this will be my first time trying that, so we'll see how that works and we'll learn as we go. Now we'll do a couple of pH problems as far as putting in your calculator shortly. Right now, I want to go to the bottom of page 46, balancing equations using the half reaction or redox method. And please notice, please remember, this is going to sound impossible to most, if not all of you, the first time through. It is not impossible. You can get it. Everybody I've taught hasn't gotten it, but those who haven't, it was usually because they were convinced they couldn't, so they didn't try very hard. We'll be going through this several times. You will have plenty of opportunities to get it. You'll have opportunities to ask questions. And after we've done a few sample problems, we're going to try and see if we're going to try and see if I can't figure out a way for you to ask me questions as you're doing them when you get stuck. But first, we will do several problems. Now, the what software? Zoom. So Zoom is not as convenient for this as EasyTalks was, but EasyTalks let me down, so we have to have something reliable. I cannot quickly switch back and forth between screens and have it switch back and forth at your end. So I can't have this screen open where you can see the instructions and another screen open where I'm doing the work. So we're just going to have to make do. Now, here we are. Let's see. Balancing equations using the half reaction method. So, steps. You see them listed here. and normally I would have you be able to write them from memory, but given the online nature of this, unless we get back a week or two before the test, I'm not going to have you try and memorize these. Now, I'm giving myself some room to work. You can't do that with your printed notes. And this is just sample problem. You can write it down or not write it down. It is up to you. Now, I'm going to start with a incredibly simple problem. Some of you are going to be bothered it's so simple. You're going to say, well, why did we have to go to all that work? I could have done that without going to all that work. And yes, it's true. The problem I'm starting with now, you could do without going to all this bother. But that's kind of like when I took piano lessons, the first quote unquote song they had to play was just like dun 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 dun. Yes, I did take piano lessons, hated every minute of it, and totally forgot it as soon as I was allowed to quit. But you don't have to take lessons to do what I just described. So why do you start with that? Well, you start with what's easy. It would make no sense to sit a little kid down on a piano, put some sort of sonata in front of them and say, well, you can't do this, so we're going to start with this. So we're going to start with an easy one that you could have figured out all by yourself without any bother, any help at all. Now let's see my pen. Get my pen back here. So let's say HCl, hydrochloric acid, plus, let's say I poured it on steel, or not really steel because that's mixed with carbon. See, I poured it on iron, and I got FeCl3 plus H2. Now, I could balance that equation off the top of my head right now, and I'm betting that many of you could too. But we don't have it there to balance it. We've got it there to learn the technique. So the first thing you see is determined what is oxidized and what is reduced using oxidation numbers. So we're going to have to go back to what we learned unit 2 or 3, and that's page 19 in the notes. If you need to refer back to that, you probably do. Several of you do. And as I mentioned yesterday, stick a paper clip or something on that page so you can find it easy if you need it. And we would say, all right, hydrogen is +1 with nonmetals, chlorine is minus group 7A, so it's -1. Now that adds up to 0 like it's supposed to. Pure elements are 0. Over here, Cl is -1 in compounds, and there's 3 of them. Whoops, that was supposed to be Fe. Fe doesn't have a rule, so what does it have to be to equal 0? Well, let's see, this is -3, so +3 minus 3 is 0. And this part I don't care about. I just care about these numbers. And hydrogen is a pure element, so pure elements are 0. Now, I know that I whipped through this. It's supposed to be review. You're supposed to, by now, have some idea what's going on with that. So now I've used the oxidation numbers, and I have to see what is oxidized. Remember, oxidized means that the number goes up from left to right. And what is reduced? Reduced means the number goes down from left to right. So hydrogen is +1 on the left, 0 on the right. +1 to 0 is down or reduced. So reduced equals hydrogen. Chlorine goes from -1 to -1. That's no change. Iron goes from 0 to +3. That is up. So iron is oxidized. Oxidized equals iron. Now, that is the first step. And it was pretty simple if you remember oxidation numbers. Now, okay, so some people look at this and they're like, wow, look at all those steps. There's a lot of steps because I have tried to make the steps as each step as simple as I can in and of itself. So next, step B, write the half reactions. One for the element which is oxidized and one for the element which is reduced. Okay, so you get that. 1 and 1 means we're going to make 2 half reactions. Now write this in your notes. For the half reaction, we want symbol, subscript, and oxidation number. So 1 and then another 1. So first of all, and it doesn't matter which one we do first, but I'm going to do the reduced hydrogen first. So on the left, right here, symbol, subscript is an understood 1, oxidation number, arrow. On the right, we're still talking about hydrogen. So symbol, subscript, and oxidation number. All right, that was simple enough. Okay, now for the other oxidized iron. Okay, so symbol, subscript is an understood 1. Oxidation number is 0. Arrow, now on the right, symbol is Fe. Subscript is an understood 1. The oxidation number is +3. Now, if you didn't follow something, feel free to find that raise your hand icon under the participants tab and we will answer your question. I will answer your question. So that was simple enough. Symbol, subscript, oxidation number. Next step, step C. And I'm going to refer back up to this page. I'm going to stay here. Let's see if I can get. Now, C and D. And D. Let me point something out. What do I want? How about the highlighter? Balance, balance, balance. So if you're not paying attention, if you're not thinking, if you're not noticing, it'll sound like the same thing. So in C, we're balancing the elements in each half reaction. In D, we're balancing the charges in each half reaction. And in E, we're balancing the electrons between the two half reactions. So we're balancing the elements using coefficients. We're balancing the charges by adding electrons, and we're balancing the electrons using the least common multiple. I'm assuming that you folks already remember that LCM is least common multiple. So we're not going to do them all three at once. We're going to do them one at a time. But I wanted you to notice that we're going to balance, balance, balance. So balance the elements using coefficients. On the left, by the way, we need to write down for this step. For this step, it is, where will I write this? Balance the elements. For this step, we need subscript times oxidation number, not hashtag. So it's understood 1 times 1 means there is 1 hydrogen on the left. No, I'm sorry, I'm ahead of myself. I'm ahead of myself. This is the simplest step. How many hydrogens on the left? Understood 1, 2. Well, 1 hydrogen is not the same as 2 hydrogens. So we'll give ourselves a coefficient of 2. So now we have 2 hydrogens on the left and 2 hydrogens on the right. 1 iron on the left, understood 1 subscript. 1 iron on the right, understood 1 subscript. So 1 on the left, 1 on the right. That is already balanced. If you have questions again, get familiar with the raise your hand button or whatever it is. Now we balance the charges in the half reactions by adding electrons to the high side. And here's where what I was writing earlier. It is coefficient times subscript times oxidation number. So two coefficient times subscript, understood 1, so 2 times 1 times oxidation number. Yes, Mandy. You can unmute yourself and ask your question, Mandy.
What if the left H, like back up to the bottom of the last page, had a or coefficient? Like, what if the coefficient was like 4 instead of an understood like 1?
You mean what if this had been H4 right there?
No, yeah. How would you balance it?
Well, then this would have been 4. So I would have needed a 2 there to make 2 times 2 is 4 on the right. Does that make sense?
Yeah.
And this would have been gone. All right, so subscript times coefficient times oxidation number. I guess I didn't write it in that order, but I'm sure I'm sure by now you folks know that it doesn't matter what order you multiply. So let's see, 2 times 1 times plus 1 is plus 2 on the left. And then we're going to want the left and the right to equal. So understood 1 times 2 times 0 is 0. Now, plus 2 does not equal 0. So how do we get these two sides to equal? Well, you add 2 to the right, except no. We are adding electrons, and electrons are negative. Well, if I added that to the right, that would be a problem. If I added 2 electrons plus minus 2, I'm sorry, negative numbers. Ah, negative numbers! That still isn't equal to 0, left to right. So we have to put it on the right. Now, this negative 2 that we just added becomes on the right, because we put it on the right, 2 electrons. We'll do more if you're not getting it. If you have specific questions, please ask. So now we'll do the second one. 1 times 1. Okay, are you with me? I'm sorry, did I just see a raise hand icon? Did somebody have a question?
Yeah. So can you not take away from the right side? And that would add it? Is it because there's 0?
If you take away 2 from 0, you'll end up with minus 2. And minus 2 does not equal plus 2.
Oh, I see.
So it is 2, the number is right, but the sign isn't. All right, so 1 understood 1 times understood 1 times 0 for iron is 0. Whoa. There we go. 0 on the left, and on the right, 1 times 3 is 3. Did I say right? Negative 0 on the left, plus 3 on the right. What do we have to do to make these equal? Well, we're subtracting. Remember, electrons in this step, electrons in step D, now you can't read it, I scribbled it over, is negative, so it has to be minus 3, and this becomes plus 3 electrons. Some people say, well, how come this was minus and this is plus? It's because it's plus negatives. All right, now listen carefully. We are done with this. That was just a tool. We don't need that. And it brings it to the next step, brings us to the next step. And the next step is one of the ones that people get the most confused about. Oh, look, my highlighting randomly is turning into gibberish again, like it usually does. Okay, step E is balance the electrons between the two half reactions using the least common multiple. The least common multiple of 2 and 3 is, I'm hopeful that you guys are with me and could answer if you were on, if you had your mics on, that the least common multiple of 2 and 3 is 6. So one at a time, we're going to multiply through. Now, don't you do this, because it's not as easy for you to fix this as it is for me. So we're going to do one reaction at a time. What do you have to multiply? Did I finish? The least common multiple of 2 and 3 is 6. So I'm going to have to multiply every coefficient in this half reaction by 3 to get 6 electrons. So 2 times 3 is 6. 2 times 3 is 6. And 1 times 3 is 3. Good? Now, see, this is what I can do that you can't. Bink. Now we're going to ignore this one for a while and do the second half reaction. What do I have to multiply 3 by to get 6? I have to multiply it by 2. So every coefficient in that half reaction has to be multiplied by 2. So 2 times 3 is 6. 1 times 2 is 2. 1 times 2 is 2. Now I've got bink. Now I've got 6 electrons on the first half reaction and 6 electrons on the second half reaction. And so I am ready to go to the next step. Now, the next step is going to be awkward. I think I'll do it. Wish my screen was a little bit deeper top to bottom. I suppose I could have the notes a little smaller. Okay, the next step is easy-ish. Let's see. Not that. Stop it. Okay, cancel the electrons and add the 2 half reactions. So cancel the electrons. Ow, you annoying thing. Now, some of you are going to say, why did I go to all that work to just turn right around and cross the electrons off? And the answer is pretty simple. Why did I go to all that work just to cross the electrons off? Because I need the same number of electrons to be used as by one half reaction as are given by the other half reaction. Everything we did till now was simply to make sure that we had the same number of electrons being given by one as were used by the other. So one equation gives 6 electrons, the other equation uses 6 electrons, and the number of electrons has to balance between given and used. So, I wonder if I can make this happen. Let's see. Nope. Now I've got some screen limitations that aren't being helpful. So 6 hydrogen on the left, 3 H2O on the right. I'm adding the half reactions. 6 H on the left, 3H2 on the right. I still need those oxidation numbers. So it was +1 and 0. +1 and 0. And then I had my irons. Fe 0 and Fe +3. And what were my coefficients? 2 and 2. Sorry, I'm making you seasick there. 2 and 2. Now, if everything, excuse me, if everything made sense to this point, you're in reasonably good shape. Now, this one. That one bothers people. And I'm telling you, use the steps. Just use the steps. Keep the steps in front of you and follow them. A, B, C, D, E, F, G, whatever. Don't try and do these off the top of your head until you've been doing them for a long time. You follow the steps, like I said yesterday, inch by inch, life's a cinch. Yard by yard, it's hard. So just follow the steps. Do it the inch by inch way. Now, we have an if-then statement. If-then, if something is true, then you keep going. If there are elements in the original equation that are not in equation F, okay? Equation F, right? Equation F is this. Was there anything in the original equation that I have not written here? And the answer is yes. There was Cl. So since there's more that I haven't accounted for, I have to rewrite the original equation and insert the coefficients from step F. So the original equation was HCl plus Fe arrow FeCl3 plus H2. So I take these coefficients and I put them in this equation, but I can't just randomly put them someplace. The 2 is in front of the Fe, so I have to put 2 in front of Fe on the left. The 6 is in front of the H, so I have to put the 6 in front of where this H came from on the left, which is right there. 3 in front of the H2 on the right. The H2 is right there. 2 in front of the Fe. Where'd the Fe come from? Came from FeC. Whoop, it was 3, not 2. So I need a 2 here. Now, there are more steps. But I'm going to tell you that right now, those steps don't apply to this problem. It says balance any non-redox reactions. Well, we don't have anything else. And then it says balance hydrogen and oxygen, but we don't have any more oxygen and hydrogen other than what we already balanced. So for right now, this is the completely balanced correct answer. A whole bunch of work, yes, but for a difficult, there are equations that are impossible to do without this. Could have done this one without the process, but we're learning the process, so we use it for practice. Now, are there any questions about this? Yes, Avery.
How'd you get the CL on the right and left?
They were in the original equation.
Oh, okay.
Which is not on the screen right now. I don't know if you wrote it down or not, but it
No,
was
I didn't.
That's fine. It was in the original equation, which is right. Yeah, too far.
Hello there.
Which is right there. So we had the CL and the CL in the original equation.
Okay.
All right, we will be doing practice on this for the rest of this week. You don't have to feel like you need to know it right now. So unless you have some other specific questions, I want you to do the PFG, which is on LMS under PFG 1. Now I am going to stop the recording at this point. Maybe if I can find there it is.